So now we get to the capital asset pricing model, also known as the CAPM. This is a very important model that we really want you to know before you graduate. So the capital asset pricing model is a very important model to learn as a finance major or as any major. Um, it's also known as the CAPM for short. So basically, what we have found, or what the equation says, is that the return on a stock is equal to the risk-free rate plus the beta of the stock, which you've probably heard in the financial markets or the news, people talking about beta, measures the riskiness of a stock, times a market risk premium. And that's just the return on the market minus the risk-free rate. And so we'll look at this formula a lot and calculate a lot of required rates of returns using this CAPM equation. So that's really what the R over here is. It's the required rate of return for a stock. The beta, like I said, it measures the stock's riskiness relative to the market riskiness. So if you had a stock with a beta of 2, then that would mean that stock is twice as volatile as the market. And the market could be like the S&P 500. And then the assumption is that the beta of the market is 1 and everything is measured relative to that market beta. So if you had a stock with a beta of 0.5, then that would mean that stock is half as risky as the market. And so here's an example. If you had the beta equal to 1, then it's just as risky as the market. And then we talked about an example with 2 and with 0.5. And then here's just a general range for betas. So could we have a beta that's a negative number? And we could if the correlation between that stock and the market was negative, like we looked at with the collections firm example from before. And so that is something that's possible, but it's not very common. And so how do people calculate these betas? Because you can look out on Yahoo Finance and you can find, look up AT&T or look up Google or ExxonMobil, and you can find what their betas are. Pretty much you have to run a regression. You can pick like weekly returns for the past 5 years for a stock, and the regression is where the dependent variable is the return on the stock, if you have weekly returns, and the independent variable would be the weekly returns for the S&P 500. And you run a regression. You can do this in Excel, and it's really easy. And you get a slope for that regression. And the slope is the beta. That's how people are getting betas. Now, different people or different companies use different methods. Some people might take the last 5 years of data, but they use monthly data, and some people might take the last 5 years of return data and use weekly data. So depending on what you do, you'll get a different beta, and there's no this is the correct way. It's based on what you decide to do, and you have to kind of go with that. So here we have an example where they ran a regression to calculate the beta based on year 1, 2, and 3. So we only have 3 observations, which is like really terrible in terms of statistics, but this is just an example, so don't judge the statistics. So you have the return on the market, we needed those, and we needed the return on the stock. So this return on the stock column, that is your dependent variable or the Y variable, and the return on the market is your independent variable or the X variable if you were putting this in your calculator, which we may or may not do that. So what is estimated, and this probably was using Excel, is that you get an intercept of negative 2.59. So you see negative 2.59 2.59 would be somewhere around here on the graph where it crosses the y-axis, plus the beta, which is the slope of the line, 1.44, if you remember in algebra, rise over run, times the return on the market. So I could use this equation and estimate a return for this stock. If I thought the market return was going to be 12%, I could say 12 times 1.44 and then minus 2.59. I would get a number as my estimate for the stock's return based on this regression. Again, this regression is not good, so I wouldn't do any real estimates with this equation. But this kind of shows you how people get a beta. Now we can also look at an example graph of the betas or slope coefficients that were estimated for the data that we had. High tech, the beta is 1.32, which it's riskier than the market, and that makes sense to have a beta greater than 1. T-bills have a beta of 0 because they totally don't relate to the market. And the collections firm has a negative beta. That's not very common in real life, but its negative beta is negative 0.87. And so they've calculated or given us a beta for each of the different investment choices that we had from before. And you can see that based on the return, the betas kind of follow in line, going from the highest beta down to the lowest beta, as similar to the expected return going from the highest return down to the lowest return. So this should make sense with riskier stocks having higher betas. Now, the CAPM is also called the security market line, and this is what, like I mentioned before, we use to calculate a required rate of return. The formula could be stated this way, as we saw before, or it could be stated the second way, where if you're given this is the market risk premium, and that means they've already subtracted the risk-free rate. So if you're given the market risk premium, you just put the number and multiply it times beta. If you're given the return on the market and the risk-free rate and beta, then you use the first equation. So it all depends on how the question is worded. And so we're trying to figure out what is the market risk premium in this example. And since we had the data for the return on the market, its expected return was 10.5%, and the risk-free rate was 5.5%. If we subtract those two, we see the market risk premium is 5%. And so what is that market risk premium? We talked about it a little bit before, but it's that extra return over the risk-free rate that you should be compensated for taking on more risk. And then there's just some estimates in terms of it kind of ranges between 4% and 8%.